Normally, as you can see, the charging ratings will be displayed like this: 5 volts 2 amperes, 9 volts 2 amperes, something like this. Now normally 2.0 slot will be given like this: 5 volts 0.5 amperes. So as you can see, it sums up to 2.5 watts. How it came? Like P is equal to VI, voltage into current. So we have 5 volts into 0.5 amperes, 2.5 watts. So what actually happens in battery charging is actually when we drain our battery, we need to recharge it, we need to charge. So what we'll give, we'll plug into supply. So if the power is more, then the speed will be more. So rate of energy, no, so rate of work done. So the energy will be transmitted very fastly, so power will be increased, means rate of charging will be increased. So there's a basic principle behind that. Now what this VOC do is actually they keep the voltage constant and current varying. So in that principle we can see like normally 5 volts 2 amperes gives 10 watts. And now what happens now in Snapdragon quick charge, in all those things we have 9 volts 1.67. like quick charge 1 is the above one and quick charge 2 is below 1. If we take it, gives 15 watts. But this VOC charging, what happens, 5 volts, they will keep the volts will be constant, but they will increase the current as 4 amperes. So it sums up to 20 watts. So power is increased. So this is a basic principle what VOC is doing. And coming to this one, stages. Now in battery recharging stage, we have two stages actually. I think you have quite experienced this. The first stage where the battery is charged from 0 to 80% is like very fast it does, and the remaining 20% is being like very slow actually. That's what so many a lot of members have said, that 20% you can leave and you can experience your 80%, just keep remove from 80% and enjoy, because 20% is taking a lot of delay. Because in this 20% they want, like this 20% charging is equivalent to 50% charging approximately in all the mobiles in general, in common. So what happens, like in the second stage from 80%, whatever the power which I have supplied in from 0 to 80%, there is a lot of power. Now this power is being diminished from 80% to 100%. They will give the power, but it will be diminished so that your battery will be safe after 100% of charging. So now temperature. So temperature is like when you are heating, like you have to supplying like at higher volts, the temperature will be more. So as you are seeing the fast charging technology, we are supplying so much of volts, like we are increasing the volts, not increasing the current. So what happens, this temperature will also be increased and heating will be produced. And now other feature is on go. On go is like while we are watching any video or playing game on like on a smartphone, so our battery will be consumed. Now while we are plugging into the to the outlet, when we are gaming or video gaming or watching a video, now the fast charging technology will not work. Like now our battery will not charge as fast as we have experienced it earlier, because what happens is while playing or playing game, our GPU and CPU will be working, which produces heat, and the battery which is being fast charged because of the higher voltage is also working, it also producing heat. So this overheating causes a damage to your mobile. So what happens, the CPU inside will automatically detect this overheating and turn off the supply of that, like it will just switch off the fast charging mode to normal charging. So this is what happens actually in the normal mobiles. But in VOCC what happens is we are not supplying excessive heat due to the higher voltage. We are supplying just constant voltage, normal voltage, so we are not supplying higher voltage, so excessive heating is not produced, so we can play video games and watch videos on the go, but I recommend not to do so. And now coming to VOC technology, this is some of the stats actually. From 0 to 75% it takes 35 minutes, and from 0 to 90 it takes 45 minutes, and from 0 to 100 it takes 1 hour 10 minutes. 25 minutes more in the last stage. I have said the last stage should be like that only. We can't change for now. If we can change, so 0 to 100 can take in just 50 minutes comparing to the rate which we have started in initially, relative to that rate, taking that rate as consideration. Now coming to some examples, take first device is VOC capable and second one is not. So 82 minutes it will take. while watching something, and the second one will take 95 minutes, say, without watching. For suppose while watching it takes the same time, because we are using VOC technology. As I said earlier, there is no damage on the go, temperature is not going to increase, and it will not switch, the CPU will not switch, the internal system will not switch to speed charging to normal charging, will not switch, because we are using VOC. And now the second will take more than 95, of course. And now coming to one more example. The first one is VOC capable, and the second one is not, and third one is not. And take the battery capacity to be, the first one 2000, just like rough figures, and second one 4000, and third one 31100 milliamperes. This is a battery capacity. Now you take after 1 hour, the first one charges up to 80%, and the second one charges 37%, and the third one charges 27%. Now if you take after 1 hour, 1600 milliamperes has been charged, and the second one is like 1480 milliamperes has charged, and third one is 837. As you can see, the first one, the capacity is low, but its capacity has been charged very fastly. That means out of 2000, 1600 milliamperes capacity has been charged. That means 80% has been charged. So that's the advantage of VOC technology. Just I want to give a rough figure, so that in figures, in numbers, you can understand how VOC technology will work. And again, so lot of new advancement has to become, and as you can see, these are some of the components of this VOC technology. Actually, they are implementing this voltage tester and detector in the handset, and they will again keep the voltage tester and detector in the charger, and they will supply using, and they are using some MCB, some chipset like thing in the charger itself for configuring out the voltage and everything, details about that, so that they will be turning off the switch, everything, some chipset they are using here in the charger. And they will be provided with a fuse inside the handset, and they will use some type of nice military graded connector, so that if they are supplying high currents, so that no damage will be taking place to the connector, the USB. And this will be available in USB-C and normal USB port. And so a lot of advancements are going to be taking place in this recharging technique. For example, imagine if you can supply a constant source power supply to the battery of 5000 mAh, suppose, in like this parallelly, 2500 in one phase and 2550 in other one, so that this will be charging at a time simultaneously, and this will give you a better results. For suppose 5000 mAh charging will take like 1.5 hours. Now if we charge like this, it will cut off to 50% of its time period. Imagine that. And so that's what I can say regarding this VOC technology. And we are expecting a lot of changes to take place in this battery recharging technology. So that's what I can say, and these are stages actually, the time and the percentage rate of charge, amount of charge it has took in the battery, and all those VOC technology. Constant voltage should be maintained, and current will be wavering, so that the temperature will be less, and on go we can experience very efficiently. So that's what, summing up, wrapping up, signing off, CY Rocket.